Hello, this video is titled What is Covalent Bonding and How is it represented the compound edition? You will see on my channel that I've also got an elements edition. I would recommend watching that one first before you start this video. First of all, let's really quickly just recap what is a covalent bond. And here you can see I've got the example of chlorine. Chlorine is an element. We're looking today at compounds. So a covalent bond is bonding that occurs between non-metals. Okay, and rather than transferring electrons like ionic bonding, we have the characteristic Venn diagrams to show that we are sharing electrons. So this is chlorine. Okay, chlorine is an element, it's a diatom, a diatom, so there are two of chlorine in one molecule of chlorine. Okay, and it's an element. And if this doesn't look familiar, you need to go back and watch my element edition of this covalent bonding topic, because this is where you will see this. So this is an element. Today we're looking at compounds, and I'm going to go through the most common examples with you. Okay, so first of all, hydrogen chloride, one that comes up really often. Now, whenever I draw these, I always draw the atoms separately, and then I draw them joined together. Now, lots of the time they will give you these empty Venn diagrams that you fill. Sometimes they don't, but I would say 80 to 90% of the time these are drawn for you. Now, in covalent bonding, like in ionic, we really only have to show the outer shell electrons. So I've got hydrogen here, 1 electron in the outer shell. Chlorine is in group 7, 7 electrons in the outer shell. Now, hydrogen only has 1 shell, so it needs 1 more electron to complete its outer shell because it can only hold 2 in the first. Chlorine has 7 electrons in its outer shell, okay, and it can have 8 in its outer shell, so it needs 1 more. So you can imagine what happens here is we have the sharing of these 2 electrons, but we represent it on the diagram like so. So that is the cross from the hydrogen. That is the dot from the chlorine that I've circled there on the left. Now, the hydrogen only has 1 cross, so I don't need to put anything else on this shell, okay? But I do need to fill the remainder of chlorine's electrons like so. Again, representative dots to show that the dots have come from the chlorine, the crosses have come from the hydrogen. And that's how you'd bond HCl, hydrogen chloride, okay? And again, you count back your electrons. 1 cross here, 1 cross there, 7 dots here, and there are 7 dots there. So the chlorine has 7 of its own electrons. It shares the 1 from hydrogen. The hydrogen has 1 of its own electrons, and it shares the other 1 from chlorine. In terms of representing what that looks like as a bond, it is a single bond. 1 dot on 1 cross is a single bond. So there's a single bond between the hydrogen and the chlorine there. Now, in oxygen, oxygen you'll realise is an element. But I'm just really quickly going to recap that to show you what covalent bonds look like when they're double bonds, because I'm about to show you carbon dioxide, and I show you carbon dioxide, we're going to see a double bond formed, okay? So although this is an element, it's relevant to our next example that I want to show you, okay? So a double bond, oxygen is double bonded. So it has 2 bonds between it, and we represent that as 2 lots of dots and crosses. So oxygen has its own 6 electrons here, its own 6 electrons there on its outer shell. Each of these oxygens need 2 to complete its outer shell, so each of them are going to donate 2 to be shared. And your final result looks like so. Dot and cross, dot and cross. Now I need to count back my crosses. I've got 1 cross and 2 cross in the shared area. So I only need 4 in the shell, and it's exactly the same with the oxygen here. Okay, and that's your completed diagram. You can see that it ends up as a double bond. Dot and cross 1 bond, dot and cross the other bond. So this links us on to our next example at the bottom here, which is carbon dioxide. I'll do that one first, okay, because we're actually going to have something that looks like so. So rather than the double bonds being between the 2 oxygen atoms, it's going to be between the carbon and the oxygen. Now, carbon has 4 electrons in its outer shell, only 4. So again, it can have up to 8. So it means it must gain another 4. So it's going to put these 4 electrons into the sharing areas here, 2 in each. Okay. Oxygen, each oxygen needs 2 electrons. So each oxygen is going to give up 2 into the sharing areas, and it's represented like so. So 2 crosses in each sharing area, which shows you the crosses from the carbon, and then 2 dots in each one, which show you 2 dots from each of the oxygen atoms. Now, in terms of rearranging and counting the electrons, I've got 4 crosses here. I've only got 4 crosses there, so nothing on my outer shell of carbon, but I will have some electrons to place from my oxygen. 2 dots from this oxygen, so therefore I need another 4 to be placed. They can be placed anywhere. This oxygen also has another 4 to be placed, and those 4 can be placed anywhere. Okay, so these in carbon dioxide you have a double bond. One dot and cross is one bond, one dot and cross is another, and the same on the opposite side. Water, a little bit more simple because we're working with hydrogen. Each hydrogen atom can only hold 2 electrons, and each hydrogen atom already comes with 1. Okay, so if it needs only 1, it only needs to offer 1 to the sharing area, the covalent bond. This oxygen must share 2 electrons because it needs 2. And it's going to put 1 here and 1 there. Okay, like so. So I've got my 2 crosses, 1 and 2. I've got 2 dots, which can be any of these 6 dots here, but I've got 4 more to place, like so. And again, they can be placed anywhere. I would always place them in pairs because it makes it easier to count. So when you count your electrons back, which again I always recommend doing, 1, 2, 3, 4, 5, 6 dots, 2 crosses from the hydrogen shared, 1, 2 crosses from the hydrogen, 2 electrons shared from the oxygen. Very last example, one of the more complicated examples that does come up is ammonia, NH3. So I've drawn out all my atoms, 3 hydrogen atoms across on each. Nitrogen has only 5 in its outer shell. Now, if it has 5 in its outer shell, it needs to gain 3 electrons, which means 3 electrons must be put into the sharing areas, and coincidentally, there are 3. So let's place nitrogen first this time. Nitrogen must put 3 electrons into the sharing areas because it needs 3. Now I've just placed 3 of the electrons. It means I've got 2 remaining, and they can go anywhere on nitrogen's outer shell. Each hydrogen atom must donate its single electron to the sharing area. There are no other electrons on the outer shell of the hydrogen, so we don't need to place any around here. Okay, I would go back, I would watch all of these examples. I'd then have a go at drawing them out yourself. Like I said, these empty Venn diagrams, or how they were when I first started, you do get given those exams, but you should be in good habits of drawing them yourself as well.